Hello everyone. Welcome back to the next training session of the SHL Technical Support Team. Today's content we want to introduce to everyone about rust preventive oil. The presentation includes the following sections: rust and mechanism of anti-rust, types of rust preventive oil, components of rust preventive oil, how to choose rust preventive oil, and the last is management of rust preventive oil. Now, let's go to the first part. What is rust? Rust is the degradation of materials' properties, formed iron oxide by the redox reaction with oxygen in the presence of water or air moisture. Several forms of rust are distinguishable both visually and by spectroscopy, and form under different circumstances. Visually, rust is brown to red depending on the degree of rust of the material. Examples are hydrated iron 3 oxides and iron 3 oxide hydroxide. Generally, corrosion is the oxidation of metal through an electrochemical process. In the meanwhile, a reduction occurs at the cathode which can produce either hydro in acidic system or hydroxide in alkaline system. According to the mechanism of rust, corrosion inhibitors can work efficiently by preventing either the oxidation of metal or the reduction. Thus, corrosion inhibitors can be classified into three main types: anodic, cathodic, and mixed. Based on the classification name, we can see that anodic inhibitors can retard the anodic reaction by forming a protective oxide film on the metal surface, requiring a critical metal protection concentration since they can accelerate corrosion when low. There are two action modes: oxidizing inhibitors that can passivate the metal without oxygen, such as chromates and nitrites. The other is non-oxidizing anions that require oxygen to passivate the metal, such as phosphates and silicates. These inhibitors will promote the rapid formation of a protective oxide film on the anodic areas. Cathodic inhibitors act by either slowing down the cathodic reaction or selectively precipitating on cathodic regions to interrupt the flow of electrons from the anode to the cathode. Unlike the anodic inhibitors, the cathodic inhibitors are not corrosive, even at low concentrations. And finally, the mixed inhibitor. Mixed inhibitors are organic compounds that adsorb on the metal surface with film formation and prevent both the anodic and cathodic reactions. The organic corrosion inhibitors adsorb onto the metal surface through the polar head. The nonpolar tail is oriented and closely packed in a direction vertical to the metal surface, forming a tight film and providing a protective barrier to avoid the attack on the base metal. Meanwhile, the physisorption of hydrocarbon molecules from the base stock by the nonpolar tail of the adsorbed inhibitor molecules can increase the hydrophobic barrier's thickness and effectiveness to corrosion. Next is about the characteristic of the material when it is rusted. Rust is a degraded metal, a mixture compound that has no strength. When 1% of iron thickness changes to rust, strength of material decreases from 5 to 10%. If 5% of the thickness changes to rust, it will not be used at all. When metal is exposed to the outside, rust from 0.05 to 0.16 mm is generated in 1 year. And 1 mm is in a wet place. Rust preventive oil can be classified as solvent-based, oil-based, and water-based rust preventatives according to the types of the base fluid. Solvent-based rust preventive oil is to use a solvent to dissolve anti-rust additives. After spraying the oil on the surface of material, the solvent will evaporate. The remaining layer of anti-rust additive on the surface of the material, so depending on the additive in the oil will have different thickness and anti-rust ability. About oil-based rust preventative oil. In addition to using additives to prevent oil rust, also use an oil film to prevent the metal surface from interacting with oxygen as well as the humid air outside the environment. However, due to the oil film, the cleaning ability after use is lower than that of solvent-based oils. Finally, water-based rust preventive oil is the least effective of the three. Next, about components of rust preventive oil. The first is a mineral oil-based ingredient, which is used for oil-based rust preventative oil. Used to workability retention. Primary blocking of corrosive substances after oil application. Restoration role in case of paint film breakage. Works as a lubrication aid during press work. The next ingredient is sulfonate, usually found in solvent-based rust preventive oil. Sulfonates are divided into different types based on metal ions such as bari, Mg, Canchi or natri. Sulfonate main function is strong metal surface adsorption for rust prevention, maintain the stability of the original liquid with clean dispersion, and inhibit the occurrence of oil stains. Polymer is also an important ingredient in oil-based anti-rust oils. Organic polymers with many absorbent polar groups can also contribute to acting as effective corrosion inhibitors. In addition, the polymer has the ability to improve the viscosity, dispersancy, anti-rust properties, and salt spray resistance. Finally is amine, often used for water-based rust preventatives oil. Amine is an effective in protecting metal surfaces by direct or vapor phase contact. Amine helps to decrease the moisture. On the other hand, they will decompose with the water absorbed and provide excellent corrosion inhibition action without foaming in aqueous solutions, and also rust preventive effect to metals even when used in a small amount. Regarding the oil film thickness, the thickness of the oil film also plays an essential role in anti-rust oil. With the same density of anti-rust additives distributed in the oil film, the thicker the oil film, the better the rust resistance. However, with the same concentration of anti-rust additives, the thicker the oil film, the lower the anti-rust ability. In addition, because the connection between the anti-rust additive molecules is not tight, creating many holes for water molecules penetrates and cause rust in metal. In other cases, with the same film thickness, the higher density of the anti-rust additive, the better the anti-rust ability of that oil. Regarding the selection of rust preventive oil, we have the following selection factors. First, the material is mentioned. The kind of material is known clearly. It is produced from steel, zinc, copper. Knowing what materials to prevent rust, we can predict how likely the material is to rust and for how long. The second is the rust prevention period. The product will be stored for how long. Third is process conformation. The base oil of the anti-rust oil should be compatible with the processing oil of the previous process to prevent delamination. Anti-rust oil does not adhere to the material, does not achieve an anti-rust effect when used. We need to know before that the customer uses metalworking oil mixed with water or not, or what type of cleaning oil to use. If they use the non-aqueous type, we should advise the customer with solvent-based anti-rust oil, or if using a water-based cutting oil, the customer should be advised to clean before using anti-rust. Next is the purpose of using anti-rust. It is used for export to foreign countries, for domestic use, or anti-rust for the intermediate process. Whether or not to wash later, after washing. If the product is exported to foreign countries, the rust preventive oil needs a long anti-rust period. Sea transportation is often exposed to salt vapors, so the anti-salt ability of anti-rust oil is high. In addition, there are factors about rust-proof oil application method and packing method of the material ensures good rust resistance, does not cause oil slicks after anti-rust, reducing quality product. Besides, there are some other factors that customers require. Finally, about management of rust preventive oil. The first basic factor that we can control is the appearance. The color of the oil will change after each use, and based on the color, we can basically determine if the oil has any problems compared to original or not. Next is about specific gravity. As a result of analyzing the usage amount, the rate rises to such an extent that pollutants are accumulated. Determine the quality of the produced oil, and also determine the concentration of additives and impurities of the oil when used after a while. Viscosity is also a factor that needs to be carefully managed. The higher the viscosity, the slower the drying rate, and the possibility of recontamination increases. Next is about the water content. As water content increases, the appearance turns cloudy, and the possibility of occurrence of rust increases. In addition, rust preventive oil also needs to be managed on salt spray test to ensure product quality when shipping by sea, and millipore test to avoid residue on surface of the product. Above is the entire content of the rust preventive oil. Thank you all for listening. If you have any questions or concerns, you can contact the SHL technical support team via the email address below. Goodbye and see you again.